What's up, what's up? Welcome back. Today we're working on my custom OS written in Rust. It's an x86 operating system, and we're starting to have the pieces come together. So we've got, if we boot, we have like memory allocation, logging, unit testing. We can like access the clock, and we can work with the outside world with Ethernet, ARP, UDP, TCP. So the idea is we now have enough that we can start like doing something interesting. And so what I thought would be kind of fun is, since we got like a TCP implementation last stream that like kind of works, right? Like we're definitely like doing TCP, but what we're not doing is we're not handling like reliable transmission very well. And we're like getting closer, but we've got enough that it would be kind of fun to implement like a web server or something. That's what I was thinking. So what I thought would be fun is if we maybe had a web server that let us visualize our memory allocator and see like what pages are allocated, what pages are free, and how those change over time. I thought that would be like kind of fun. Maybe you could do even like heat maps. I don't know. We'll see. We'll kind of like just start making something and see how that goes. And so where we can start is we can start with serving any web page, right? And then once we have got that working, we can start trying to get a little bit more fancy with it. So I think, yeah, that's probably it. And probably we can just get moving. So, yeah, let's just start moving. Okay, so that's one. Okay, so I guess the first thing that we need to do is set up like a TCP listener on port 80. And maybe we just start looking at what an HTTP request looks like, and we can like move on from there. So where's our demo? Our kernel demo, he has a TCP listener, and let's just make a TCP listener on port 80. And instead of an echo server, we'll just write down what we got. So we'll do this. And if we run now, our OS, well, oops, missing some environment stuff. If we run now, our OS should boot up in QEMU. As we got here, we've got some logs coming to the VGA buffer as well as to the serial console. And if I open up a new browser and I try to go to the IP of my OS, we should get something interesting here. So here we can see what the HTTP request is. It's a get with a slash and with HTTP 1.1. And now we just have to like serve something back. So I think what we can do is we can start looking at like HTTP messages. And I think it's Mozilla docs are pretty okay here. And without reading the spec directly, I feel like it's fine to just like start kind of throwing it together. It looks like it's request method, URL, and then HTTP version. I wonder if there's like an HTTP spec somewhere. This document has been suspended. What does that mean? Okay. So probably we have something down here that says like start line is the request line status line or status line. So let's look at the request line, because that's really what I'm most interested in. That's here. So method sp request URI HTTP version and then a end of line. Okay. And probably, so we have like method is one of these guys, simple. SP is going to be something. How do we find out what SP is? Is that like in the table of content somewhere? Request URI. Sure. And then how do I get to the like, I want to make sure that I understand like how to validate the version is what I'm trying to figure out. So the request is request line, general header, blah, blah, blah. Okay. Method, SP, HTTP version. Oh, SP is probably space. Yeah, SP is probably space. So we have like method, space, request URI, space, HTTP version, end of line. Okay, simple. So we can we can break on the first line. We'll get this, and then we can separate by spaces, and that should be valid, which probably means that like request URI and HTTP version aren't allowed to have spaces in them. Bing, bang, bam. Assuming that SP is space. I wonder if somewhere that's like defined. SP. Maybe SP. Aha. Sick. Okay. Cool. So that's straightforward. So we'll look at our request and we'll try to figure out where it's going. And then we can like start routing stuff, but it doesn't really matter, right? I guess we can assume if we're trying to do like the dumbest implementation possible, we actually don't need to parse this at all, right? We can assume we can redirect all requests to the root and we'll just see where it goes from there. So I guess what we need to do is we need to send an answer. So what's a response look like? Status line followed by headers, followed by a double new line, followed by a message body. And so I think that if we just like, let's just see if we try to write into our connection a like static thing. So we'll say that our what is the response line supposed to look like? How did I get lost so quickly? What the heck? Response line. So it's HTTP version, which we'll say is HTTP 1.1. And I think that's what we saw here, HTTP/1.1. Okay. Status code. So we'll just say that this is a status 200 no matter what, which means that like this is a good HTTP response. And what is the reason phrase? Status code is a 3-digit integer result of the full attempt to understand and satisfy the request. These codes are usually blah, 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 blah. Sure, I don't care about that. I want to know the reason. Reason phrase equals text. So what does it say about that? Reason phrase listed here are only recommendations. They may be replaced by local equivalents that are without affecting the protocol. Okay, so I can write anything here. So I'll just write okay. Okay. And I think the CRLF means that you need the carriage return and line feed, which I think is /r/n. Carriage return. Actually, it'll probably say in here. Here we go. CR is the carriage return, 13, and the line feed is number 10. So I think that /r is 13 and /n is 10, but we can probably check that pretty easily. If we, how do we test this? If we just say rn and turn this into a byte string, so what's the Python string to array? Of integers. I know there's a way to do it, I just don't remember. Sure, so you can say list. No, but I want the like integer equivalent. There is probably some. Oh, you just say int. Okay. So I can say int r. R strip. Nope, that's not working. So am I missing results of array int results of array strip? That's not doing what I want. Python ASCII number 4 character. Yeah, that should work. Oh, ord. Is that right? Ord /r, ord /n, and we know this is 1310, so the /r/n is what we want. Okay. So we have HTTP /r/n, and now we want to put in another /r/n. And then we can put in like hello. And I think that should be fine. Now, I don't know how to concatenate or do multi-line strings in Rust. I always forget this. Oops, I didn't want to lose the document here. Is a two-line string the same as line 1, line 2? Oh, really? You just write the new line in and it doesn't count? That's interesting. I didn't know that. No, they're saying that that's not true. Oh, okay. Am I high? What am I missing? Okay, so this is valid. Oh, it's because this /r/n are outside the quote. Oops. And here we say hello. Okay. And this should be as a byte string. And maybe we need to ampersand it? What doesn't it like? Into? RC new maybe is what we have to put in here. What does it? This is weird. I don't understand what the problem is. It's really struggling with like type conversion. And it must have something to do with this like into RC U8 thing that we're doing for our write. Maybe we want to do maybe you need to do something like convert this to a slice or something to get into the RC. No, I don't know. Maybe a cargo check will give me something more useful. So from RC U8 is not implemented for this, so maybe I'll put a star here. Cargo check. From RC U826 is not implemented for RC U8. How is that possible? How is that possible? I guess I saw, we have something here where we've done this before, where we did a write, connection, write. Oh, I just have to specify? That's so stupid. So if I put this U8 like this, will it compile? Oh, that's fucked. But, okay. That's fine. Cargo check. Oh, actually, that still doesn't like it. Because U8 is not sized. So can I do, alright, RC stir? Didn't this work in the TCP test that we had? We did this exact same thing. We did connection.write, and we put an RC stir, oh, from. Okay. Okay, sure. So does that work? Cargo check. Okay, nice. And then we await this to actually send it out. And now, if I run this, and I try to load this web page, do I see anything? I guess I can maybe... we do get it printed. So what if we cargo run and we try to curl ourselves instead? So that's HTTP 192.168.2.2 and port 80. Header without a colon. Oh, maybe I need another new line. No? Can I look at the raw response? I think it's like this. Maybe I have to close the connection before this works. Can I maybe ask for something if I do like a netcat to 192.168.2.2 and I say support 80 and I do a get slash, oh whoa, what the fuck? I didn't like that. Why not? Oh, because I'm not running. That would do it. Cargo run. Okay, so I run this and I say get slash HTTP 1.1. And I do get back a response that seems somewhat reasonable. But I guess maybe I have to close the connection before HTTP use that. So let's look that up. I think HTTP TCP close connection maybe. A typical HTTP session. Sending a client request. Yep, subsequent lines request an HTTP header. The final block is a blah, blah, blah. So here's a request. And the first line starts as the acknowledgement of the HTTP version used and response code. Then we have HTTP headers, a data block. And I guess I don't really understand why it's not finishing, but I guess maybe the only way it knows is if we close the connection. So I guess we need to implement TCP connection closing. So I think that your issue is that you have a space before the last RN. Oh yeah, that's actually a good point. That is a good point. Let's see if that is it. Okay, so this still never resolves here. If I curl here, let's try curling it directly. So, okay, we do get a response, but it doesn't have the final content in it. Probably because I need maybe an RN at the end as well for it to be rendered out. Click a run. Curl. Okay, that looks promising. Curl's at least getting it, but the curl connection isn't closing. So I do think there's still something a little odd there. Where maybe I wouldn't be shocked if the TCP connection had to close to indicate the end of the response. So I guess let's just try that and see. Or maybe I could Wireshark a normal connection. Is that what I want to do? No, I'll just try it because we have to finish a connection anyways. Or I guess maybe I'll Google this. HTTP TCP close. HTTP end of response. Maybe this will help. If both the client blah blah blah. Oh, we need to send the content length in the header. That'll do it. That'll do it. So we can say that the content length is 5. And maybe that'll do it. So we'll cargo run, curl. Hey, okay, so that gives us something. The fact that we closed early is indicating that maybe we need a bigger number here. So let's just kind of see what that looks like. Okay, if we just start spamming different numbers. Yeah, or we could look up what it's supposed to be. So we can look at content length. And content length is the size of the entity body in octets. Okay. Sure. So let's start with 5 and see maybe what we get if we try to load from the browser. I'm missing the slash of the content length. That would fucking do it. God, you're a sharp one. You're paying attention. Okay, so this guy still gets nothing, but what if I curl him? He's getting something that's reasonable. Okay, can we like maybe see? We're closer. We are definitely closer. So I guess why would Firefox not finish, but curl does? Okay, so curl only finishes it if I run -d. What is man curl? I forget what the -d actually does. Dump header. Okay. Sure. Okay, I'll try closing the connection. I wouldn't be shocked if that is required, because just is my guess. I guess I don't have like a good reason for that. So here I guess I drop the connection, and then on connection drop in my TCP implementation, I have struct TCP connection. Here I can implement drop for it. And here we'll have function drop, which takes itself by mute. And I guess what I would actually have to do here is I would have to send to like the normal TCP service that I've got running that I am ready to close. Because like the way it's modeled right now is we have like connection. And we have like main is like polling this connection. And when he writes data to the connection, he has this like channel that goes from connection to TCP and TCP back to connection. And this doesn't actually do anything except like queue data to be written over here. And then when I call into the TCP service and I say like, please like do any work that you have to do, that's when stuff actually gets written out or read back. So here, in order to like get the TCP service to close the connection, I have to say, instead of like trying to send some data over this channel, I can send like a finish message, like fin. Which means that like what I'm sending here no longer can be just like a chunk of data, but it has to be like a message, right? So I can say like connection message. And one of the things it can be is like data. And one of the things it can be is close. And so now this guy has to take in a connection message. And now if I start just like compiling, we can expect problems. And so we'll just go back through these one by one. So one of these, this normal write should be sending connection message data, this guy. 513, we're having an issue, which is that the RX, this channel is getting the wrong type associated with it in this state. So in our like TCP service, we have like a bunch of state associated with the connection, and we just also have to apply that same change here, where this is going to be a connection message now. And we cargo check. And now all users of that are going to be probably angry. I spelled connection wrong here at line 340. So this is connection, should be connection. And then in 633, here when we like try to get data from there, we're now seeing the wrong thing. So we can say, let's see. If let some data is this, we can like match the data. And if this is connection message data, we return that. Otherwise, we would try to close the connection. So here we would have connection message close. And here we should close connection. And for now, this is unimplemented. Okay. So now what happens if I try to compile? We have a problem. Oh, so this is to send. Oops, this is the wrong section. This goes in this chunk. I was reading from the wrong queue there. There's two queues, one of like data that I'm trying to resend and one of like messages that are coming in. And so I just accidentally put the extra handling in the wrong section. So now this compiles. And if I cargo run and try to curl, nothing should break. Good. But if I actually try to write this close message, we should crash, which is good. That means that we're on the right path. So I can look at TCP connection, and in this drop, I should just self.tx.send connection message close. Now this is a problem because this actually requires like this send function on my channel is an async function, but we actually can't use those in this context. So I wonder if there's a way for me to get like a synchronized message across, or if I'm gonna have to get a little crazy here. So just let me think about this real quick. Okay, so the reason this is async is because this like async mutex that we have needs to be checked every once in a while. Okay, but we could maybe like just try to lock it. And if it fails, we'll log an error. So here we'll use try lock. We'll say if let sum guard is equal to this, else error failed to send message. And here we will then do guard.pushback val. Maybe here we'll, instead of logging in here, we'll return a result. And this can be a try send error. And here we'll just have like mark a struct as try send error, just so we have it. So pub struct try send error, just so we have like a type to use to like flag the failure with. And then we say, we can actually restructure this a little bit. We can say let guard is equal to this. And there's this like okay or thing that lets you convert this like optional response of it, like this optional lock of a mutex will turn it into an error. Nice. And then we have guard pushback val. And then we flag success. Easy. Oh, we need to put this as mutable so that this works. And now we can go back to our drop of our connection. Impl drop. And we can say try send. And now in here, we will log an error if this is a problem. I think that we should dodge this, but it's worth checking. So if this is error, we error and say failed to drop connection. Okay, great. So now when I run this, I expect that we will crash when we try to curl, because we'll open our connection from the curl, and then it will talk to us, and then we'll try to drop the connection. Perfect, and it's not implemented. Very, very nice. And so all I have to do is figure out how to implement dropping connections, which I assume is just creating a TCP, like a TCP message with the fin thing set. Let's see. TCP close. Or I think it's in Wikipedia has this TCP state machine. Where is it? Oh, here we go. Connection. I think I just saw something about like closing in here when I was scrolling. Maybe not. Scaling, blah, blah, blah. Close. So Interesting. So here I probably have to actually move ourselves into a state of trying to close because there's like a handshake thing that has to happen. Right? If I don't act the finish, then maybe we have a problem. Let's just see. 4-way handshake. When an endpoint wishes to stop its half the connection, it terminates a fin packet, which the other end acknowledges with an ACK. Therefore, a typical teardown requires a pair of fin ACK segments from each TCP endpoint. After the side that sent the first fin has responded with the final ACK, it waits for a time before finally closing the connection, during which time the local port is unavailable for new connections, blah, blah, blah. Oh, but you can replace it with a fin and ACK, sure. If the host closes the connection while still having unread data, the host sends a reset signal instead of a fin. This assures that TCP application is aware that there was data loss. I wonder what happens. So let's not get crazy here, and let's just send a fin from our side. And if it works, maybe then we don't have to go any farther, right? Maybe the browser will still, maybe we'll be like, okay, and it'll just work out. So now we're getting into this kind of weird state where we have multiple paths here. One is that we got like just raw data that we're trying to send out. And one is that we're trying to like construct a special TCP message. So probably what we actually should do here is we will generate the TCP parameters manually and then handle the like common stuff after. Right, so here are, instead of just returning the data, we generate the TCP payload or whatever the parameters. Same here. And here, we, instead of running this guy taking in data, he'll take in TCP parameters. And they'll be called params. Okay. That's probably fine. Yeah, okay. Sure, that works. And I think that just still compiles. Close. We need to keep our state in here. So this isn't called connected state. This is called connection in this context. And probably here we need to write like ref mute. Okay. And oh, this is annoying. So this is a problem because we have like the reference to this guy isn't dropped until after this like else closes, or like this if block. But we need it to, so we probably maybe do something like this. We can move this all into an else block. And then we have to like manually drop this after. So we make like a new scope probably. And we say, let data is equal to this thing. And that will force a drop of the mutable reference. Then we can do this. And these guys will now be, there's like a chance that this is like nothing, right? This is either going to be like a, hey, there was something to do, or there was nothing. So we need to wrap these guys in poll ready, like this. And now there's an extra option of poll pending. And this is just a continue. We just don't do anything. Okay. Cool. Cargo check. Does that actually compile? Surprising. I actually thought I was going to have more problems with that. Cool. So if I cargo run this now, I think that everything is still in the state that it was before. Nice. We do start to get a response back, and then we crash. Great. And just double checking again that the browser does not resolve anything here. I just want to... Oh! Okay. So that's something. We actually are getting a response back without properly terminating the connection. So let's just double check that I didn't make a mistake in my previous tests and put a continue here, which should say, like, don't try to close the connection. Okay, so I made a mistake somewhere, which is great. That just means that we don't have to close the connection and we can skip that, like, you know, extra work that I wasn't really planning on doing here anyways. Okay, so that's pretty cool. We are requesting some, like, an HTTP thing from our OS. It's giving us a response, so if we look at the response here, it just says hello, and then we render that to the page. Great. So now let's try to look at what, like, a normal response looks like. So if I go to Google, if I remember correctly, he has to tell me that he's sending me HTML with this content type. So we'll shove this guy in there. That's here, so content type text HTML. We'll put the body in here separately. So this is going to be, for now, hello. And here, we're going to inject the body length. So I think we can do this. We'll say string. We'll make this a string, or a format string. Fuck. I just crashed my language server. Classic. So we use format from the alloc crate. And then here we can, like, make a format. We can call format, which will basically give us, like, a formatted string. In our string, we put in the body length as the content length. And now we just have to convert this string into a, I think it's 2vec, or I want to, like, convert it into a vector, and then that vector should auto-convert into a shared reference. So string to vec rust. I'm sure there's a way. String to vec-u8 is into bytes. Perfect. Okay, so now this guy should also be the body. And are we chilling? Cargo run. And I refresh, and that's looking promising. Oh, it's actually not looking promising. If I try to, like, big refresh, it halts, freezes again. So why was this working before? I feel like I didn't change anything. Maybe there's, like, some caching that was happening that I've messed up. So let's go back into TCP and bring back this crash and see if we actually get, like, better behavior if we crash. No. Maybe the content length is wrong now. Maybe I made a mistake there. So I'll just undo until the point where it was working, which was here, I think. Oh, I'm an idiot. Once again, I forgot /r/n. Okay, let's try that again. There we go. Mwah. Cool. Okay. So now we can start trying to like make like this can just be like a normal HTML file, and yeah, maybe that's fine. So we'll say that we got a simple HTTP request response, and that was at around 40 minutes into stream. And now let's try to like start injecting some interesting info in there. So I guess what would we want to do here? We have like memory allocation info. And maybe what we want is like we want a web, like a static page. Sorry, maybe saying static is wrong. We kind of want like an HTTP or an HTML JavaScript pair that like is like the scaffolding for how we're going to set it up. And then maybe we want like a different API that just gets the memory allocation data directly. And so then we actually have to start handling like routing info. So that seems pretty reasonable. So what we can do is we can like look at the data, and we can look at like the first line. So the first, let's see, sorry, this is a, data should be, this is going to be like a byte, like a bunch of bytes. And I want to convert that into a string so I can work with it and then parse it. So maybe what we'll do is we just put a function like somewhere. And we'll call this function like handle HTTP request. The input is data as a U8 slice. And the thing we get out is a result where we either get the response. So on success, we get the body, I guess. We'll just give it like a U8 RC U8. Or maybe we give it like a vec or a string. We'll give it a string. Fuck it. And on failure, we'll give it like some failure. So for now, we'll stub in nothing, and later we'll figure out what that should be. We need to include string. So here we just shove in a string in here. Great. And here we'll just say hello.into as a test. Okay. So now we will get this request, and we'll call handle HTTP request on the data. And we will match this response. And if it's okay, we'll send this. But if it's a failure, we'll write this. We'll write an error 500. And maybe this just works as is. There's probably a problem. First of all, it shouldn't say okay. It should say internal server error, I think. And then if I remember, like, maybe we still need the content length in here. So we can say, like, content length 0. And I guess here we don't need this to be a format string anymore. Yeah, all right. And what's it complaining about here now? We're close. We are close. Hello. Right, because this doesn't have the toString implementation. Okay, sure. So we'll just include, I think it's string toString is where that toString comes from. Okay, so now the idea is that, like, if we get this data and we fail to handle it, then we'll just send internal server error with content like 0. And maybe it would be nice to test if that works. Do you really have made your own custom OS? Yeah, yeah, if you want to take a look, code is available at github.com/Sphere4 stream OS. And yeah, we've, I mean, calling it an OS might be a little bit, maybe that's a little unfair, right? Call a kernel maybe is more fair, but really, like, we're far, far, far from complete, right? So it's not like we have like an alternative to Windows. We just have, we have an operating system that boots in a virtual machine and can handle TCP requests. Or calling it TCP request is probably incorrect. Can handle TCP packets, and you can do like respond to them and stuff. So what we're trying to do is we're kind of trying to prove that we could make like an HTTP server, do something interesting, and yeah, that's where we're at. Okay, so let's test if this error handling works correctly. So let's just first return error from this handler. And if I run this, we should see, when I try to use this, internal server error come back. So I think there's a way, I don't know why the response data isn't visible, but we do get like an internal server error, so that's good. That means that our like error handling is working correctly. And if I can't remember, if I refresh this, does it work correctly? Yeah, sick. Okay. And control refresh, solid. Okay. So now let's see. So the first thing we want to do is we want to route, depending on like where the request goes, we're going to want to serve different data. So the first thing that we want to do is we actually probably want to like get the first line. So we can say data.split. And probably we're looking for like the first line feed. Maybe we say like we take like an iterator and we want to like, there's a way to like get a subslice until that of the data up until that point. So I think it's like maybe like position. Yeah, so we can find the position of this. And here we're already seeing problems. So we need a, let's look at what the API docs there. So it's position in Rust. Iterator position. So this takes in a predicate, which takes in self.item. And we actually have a problem where it can't be item. We actually are trying to find like a subslice. So maybe our like slice APIs will have a way to like search for the first occurrence of some pattern. Let's see. Is there like a find in here or position? Partition? I'm sure there's something. So we can search for like a single element, but I know that I'm certain there's a way to search for a substring. So Rust search sub slice. Here we go. So they have, oh, you just say Windows. Yeah, okay, that works for me. So we're looking for a carriage or like a carriage return line feed. So we can just say that we go Windows 2. So we're saying that like we're looking for the first occurrence of this. We're getting an iterator over like 2-byte chunks, and then we can look for data equals this. Nice. Okay, so what we should find is we find like the first position where that occurs. So we can say let first line end is equal to this. And if this doesn't return anything, we can say okay or incomplete HTTP request, which doesn't exist yet, but that's okay. So we'll say struct incomplete HTTP request. And for now, since that's the only failure, we can just return that. Or we say, okay. Unimplemented is the rest of this function. And if we have the first line end, then we can start finding the route. So we'll say let route, or is route the right word? we're looking for like what they're looking for. So what is the, I'm sure that the HTTP spec will tell us what the official name for this is. So request line has its request URI. That's what I'm looking for. URI is equal to, or so say let request line is data up to the first line end. And we have to borrow here. And the URI is going to be the first thing after a space. So we can actually say that the request line should be split by the value of space, which I think that they have written down here somewhere. I have to find which section this was written in, so I don't have to scroll like this. This is in section 2. And so we are looking for space, which is byte 32. Or we can say, we can just define this as a space like this. And so this should take in a byte, and we say this is split if byte equals this. And we need a star somewhere, probably here, to dereference. And then we can say that we want the second thing, which is the first index. So then we can say let URI is equal to this. And we can again say that if this doesn't give us an answer, we have an incomplete HTTP request. Okay. So we can match URI. And the first thing that we're looking for is like the root URL. And everything else will be, we'll return a toString for now. Right, just as a proof of concept. And this should be an OK. So we'll say let ret is equal to this, and we'll wrap the ret in OK so that we can flag as a success. And here we'll say hello world. Okay, so now what should happen? If I run this operating system, and I try to go to that page, so I should get hello world if I go to the root, and if I go to literally anywhere else, it should say uh-oh, which is really good. So that means that our route parsing is like working somewhat correct. And if I were a better developer, I would unit test this so that we have like proof that it's working and that we don't regress. But for now, I'd rather just keep moving. Okay, so if we get a slash, we are going to return just the content of, let's see, we're going to have some HTML file. Okay, and we can return include stir, I think it's called, and we can say that this is going to be in a resource index HTML. And we say toString. Okay, and now I just have to edit res, or make dir, I guess, make dir res, so that we have somewhere to put it, and we can say edit res index HTML. And I think I put doc type HTML in here. Why won't this write? Oh, I have to edit res index HTML, my bad. Not // So here we'll put doc type HTML, and at the head, finish it off, and then body, and maybe put like a header, hello. Just to prove that I'm doing this right. So now I have to compile. And here we get uh-oh, and here do we get like a header that says hello. Very nice, very nice. And if we look at the response here, the raw is like an HTML document. Cool. Cool. So what's next? Next is if we want to do something interesting like if we wanted to visualize our memory allocations. we should probably format those memory allocations as a bunch of JSON. Then we can like pull those in from JavaScript, parse them, and once we've parsed them, then we can like visualize them in some way in our web page. So the first thing that we're gonna have to do is we're gonna have to like look at the allocator. So we can maybe make a new page that says like allocations. And here we're already starting to get into a pretty interesting problem. So right now our HTTP request handler is only returning strings, but really it should return, this is a problem because our response is hard coded as HTML, but we actually have to have a different content type depending on which URL it's gone to. So this is actually going to return a HTTP response. And in this HTTP response, we'll have the body, which is a string. Great. But we also need headers, maybe. And that's going to be like a hash map of string to string, basically, right? I think that's what the headers are. And then we can like implement a like toString. We can like stringize this automatically. So we can say core format display or HTTP response. And we'll just like have this converted into what we were doing before. So this is basically this guy. So what we want to do here, we have a few things to pull out here. We have to set the HTTP version. So it'll just say write the port to the formatter, this guy. Sure. And I forgot a quote somewhere. There we go. And then we say for header and headers, for each header, we write out the key, then the value, and then the new line. So easy. And then we put up the body. So we write out an extra new line here before the body, and then we write the body. So I guess that just can just sit in this like this. This is self.body. Okay. So we forgot to put in the arguments here. So this is this should be for key value in headers. But key value. And we need to put an OK at the end of this so that to say we succeeded in serializing. Very nice. And then for each of these guys, we need to put the content length automatically. So I guess we'll say that the headers will automatically inject a content length one when we construct this. So we make an HTTP response. And when we make one, we take in the body, maybe. Sure. And we'll take the body as a string. And maybe we'll also take in the content type, because that's the only thing that we're trying to parameterize right now. And we'll also take that as a string. And we'll say that our headers is a new hash map at first. And then we're immediately going to put in that the headers content or insert content length is going to be the body len, and the content type is going to be the content type. This needs to be converted to a string. And then the body is this. And so now we can return HTTP response with headers and body. Okay. So there's a lot of stuff that isn't going to compile again because where we've changed types and we haven't changed the way they're used yet. So let's try to find those. Okay, so let's look at the callers of this guy. So this is going to be a response here. This is also going to be a response. That's not also going to be a response. I lied. And I guess we just say we write response to string, right? Because we have the automatic conversion. And maybe then we say into bytes. Is that it? Maybe. Okay. And now when we handle our HTTP request, instead of including a str, we have to make this guy. So we'll say HTTP response new. And this is the body. Great. And now the content type is just going to be text HTML for this one. And for this guy, we'll say that's JSON, and for now, we'll just make a temporary string. So we can just for testing. So that we'll just say that this is like test 4. And let's see if this parses correctly. This also needs to be converted. So this was uh-oh before. And really, this should be a failure, but it's fine. I don't care. So we need to run this, or else our HTTP responses, like nothing happens. So we run this. We get hello at the root. Great. If we go to allocations, we get back JSON that is parsed correctly by our by Firefox, which is great. And that's all we needed. Okay, so now the question is, let's try to get like a list of our allocations. So it's been a while since I've been in here. Let's see if there's this was a month ago when I implemented this, so it's been a second. But I think if I remember correctly, our allocations, the way we implemented this was we have like a range of physical memory. We're not doing any memory paging or anything. And if I remember correctly, we have a pointer here at the start of our memory region, we have like a free segment structure. And then when we allocate this free segment structure has like I think it just has a size. Let's see, free segment, just a size. Oh, it's got a size in the next free segment. So the idea is that like maybe there's like a used segment here. And our free segment says like, I'm this long, and the next free segment is over here. And then from every time we allocate, we come from the back, we like chunk off some memory. And basically like this guy just shrinks, we just shrink him. And if we did like another allocation here, we'd shrink him again. And then if we were to free, maybe we free this guy on the right. This guy becomes free. And then we insert a new free segment here, point this guy to this guy, and he's got a new length. So we should be able to visualize our entire memory range as our list of free segments, right? If we just had a way to serialize all of those as JSON, we could like stick those in an array, and we could put their like locations and size, and then we could visualize those in HTTP or in our HTML somewhere. So there's probably some function that we have that walks the free segments. Like when we allocate, we have to walk them. So how does this guy work? So he gets the first free block, and then he just walks the pointers. Yeah, sure. So do we have a function to like log them or something? Find header in it. There's no like automatic give me all free segments. And our free segments are probably not public. The struct itself is, but not the values aside. Sure. But we can just we can just make a free function to get what we want. So we can say pub function. Oh wait, hold on. If I remember correctly, in our unit tests, we definitely had something. Capture alloc state. Let's go. This is what I wanted. So this guy, but he only gives out a list of 100. So maybe we will put in an n of usize. Use this as the output. I thought there was a way to do. Oh, maybe we're at const here. Perfect. Okay, so the reason that this is a flat array, like instead of a vector, is because I was worried that capturing the alloc state would change it. Right? If we allocate a vector and we start pushing into it, like it'll change as we push. So instead, we'll just make a compile time limit on how many allocations we can track. Is that reasonable? Not sure. Not sure. Well, that's okay. Okay. So I guess we will make we'll capture this and you know what? I won't reuse this function, I think. I think I'll just make a new one. Because the requirements are a little different. So let's see. I guess the first thing that we want to do is we want to walk the list. And for each item in the list, we want to push into some vector. I guess it's okay. Let's try doing like a vector, or maybe we'll just return this directly as a string, a JSON string for now. And we'll say this is alloc state JSON. The first thing that we do is we find the first segment, which is this guy. And we can say, while we walk the list and it's not null, we will jump to each segment. So we'll say list IT is equal to list IT next segment. This should walk the whole list. And we'll look at the value of each item. So we'll say that what is the type of list IT? It's a pointer. So list IT as usize is going to be like where in memory this is. And we're going to have its size, which is going to be star list IT dot size. And then for each of these, we're going to append to our string. So we'll say let ret is equal to string new. And what I'm concerned about is, like, I don't know if there's like iterator invalidation if we're allocating while we're trying to find something. But we'll find out if there are problems as we go through. Okay, so now we have our pointer and size, and for each of these, we just say this is a mutable thing. And we'll say ret.push stir. And what are we going to push? We're going to push an item in here. So this is going to be test, or the element is going to have a size, which is size. And it's going to have a location, which is p. This is going to have to be like alloc format this, because we're injecting shit. And then the parameters are just p and size. We've messed this up somehow, so what have we forgotten here? because of this brace. Invalid. Oh, cargo check. I want more descriptive error message. So we don't have string imported here, so we'll just alloc string. We'll cargo check again because we're seeing compiler errors. Oh, I guess I have to escape this. Maybe? I don't understand what is going on here. The error says that there's expected closed brace. Oh, I see. Because the open brace thinks that it's a part of a format string. It's not. Aha, okay. Okay, so now we have this string push, and then we can just say we return red at the end. Okay, so now we should have like a JSON blob that shows where all of our allocations are. And so now if I go to main, maybe here I can say, maybe I can just grab it. So I can just say allocator alloc state JSON. And let's just see. So let's look at our allocations. And okay, so we are getting a list here. I think that this probably isn't parsing correctly. This is almost certainly invalid JSON. Yep. So we have a couple things that we have to do here. One, we have to put a from stir. We have to put a open brace here and close the brace here. And we have to put commas in between each element. So maybe what we do is we, on the first one, we don't put a comma in front, and then all the other ones we do. And I think that there's like what's the way you handle this again? You get an iterator, you handle the first one, and then you handle all the second ones differently. Whatever, we'll just say let moot first is false. I hate having these like bool conditions, but I think it's the easiest way to do this for now. So here, we set it to false. On the first iteration, it should be true. And if first, we say else, we push a comma. Okay, cargo check. We forgot to use alloc string toString, and here instead of using from str, we'll use toString. So we'll do this. Okay, and this compiles, so we can cargo run. And is this valid JSON now? Does this parse? We're still fucked. So why? We have an array. We have comma separated elements. Expected proper name. Oh, it's because we forgot to put quotes around our property names. So here we throw in some quotes on these. And we cargo run. And there we go. Okay, sweet. So now we've gotten back an array of all of our allocations, and the only thing we're missing now is like the total size of our memory space. And if we have those two pieces, then we're chilling. So maybe we actually need to inject the start and end of our memory range, because when we get info, when we boot, the bootloader, he says, hey, you're allowed to use these areas of physical RAM. And those areas of physical RAM don't start at 0. So we have like this range of start to end, and these pointers are in absolute space. So all of these locations are actually going to be relative to the start. So maybe what we do here is we're going to start with a dictionary, and it's going to have size, and then we're going to have to put the size in. Like this. And then it's also going to have allocations, maybe. And then we open this, we start our array. And then when we close it all, We just have to put the extra curly brace at the end. And for now, I'm just going to write 100 here just to test. So I cargo run. We should still get some valid JSON from this. Which I do. Size and allocations, that's what I wanted. I wish this fucking new line wasn't like this. How do I fix that? I just put a backslash here. Okay, so there we go. So we have valid JSON that has a size and allocations, and now all we have to do is inject. All we have to do is inject the size directly. So this is going to be, we don't actually want size, actually. We want start and end. Okay, so these are going to be injected by the formatter. So this is alloc format. We don't need this toString anymore, and then we can say alloc, where do we like see the start and the end? So on initialization, what does our allocator have the start and end? He only has the first free segment. Oh, that's fucked. So we actually don't write down the size. So I guess we just can say here, we'll just write down the start and end when we parse this. So we'll say the start is a usize and the end is also usize. Then where do we put this? Oh, so here, these actually need to be atomic usize. Because what happens is we shove this guy into static memory on OS boot, and then modify his internal things on initialization. So that's fine. We need to include atomic usize so that we can modify him in static space. And then start, we'll just put his like atomic usize new 0. And we'll do it for end as well. You get a better JSON view in Firefox if you make the content type application JSON instead of text JSON. Interesting, let's see it. So let's try that. And then here I will just, I have to punch in 100 or something just so that I have something that will work temporarily. I have to do this like double brace again, and we compile. Let's see what the application JSON looks like. Oh, I see. Yeah, I guess it depends on what I want. That's interesting. I forgot about that. Thanks. Good call. Yeah, I guess you're right. That is just better. Because you can just click the raw button and you just get what you want. Yeah, it's just better. Sick. Sick. Thanks. Good tip. Okay. So now I just need to inject the start and end. So here I can actually say that the start is going to be alloc start load ordering relaxed. And this is going to be the same, but end. And then just on init, we have to set the start and the end. So function init. We find a big block of RAM. We find its segment size here. Okay, so here we can just alloc for start store, and this is just going to be the address of the first free segment. So that's segment as usize, and we need to store this as ordering. I don't know, release, I guess. And here we have the end is going to be segment as usize plus segment size. Okay, and this should be end. Cargo run. Okay, let's see what we get here. So when we refresh, we do in fact get a start and an end that's sane. This actually shouldn't be allocations. This should be the inverse of allocations. This is free segments. Cargo run. Not that it matters, but I just want to make sure that I don't make a mistake there. Okay, so we have free segments. Great. And these are all within this range, I think. 1340866, 1340865. And these are kind of like coming backwards. Cool. So we have all of the data we need to visualize. So I think probably what I'll do is I'll make like a bar, just like a big box, and I'll color it one way, and then I'll I'll make new boxes for each location and offset them by like some percentage of the bar with CSS and put them on top. So I guess the first thing to do is just like start stubbing out our HTML file. So I think you can just inline like put script here and console log hello world. I think that if I do that and I go to the main page, well, nothing will happen because I need to run my server. And then I need to go to this location. I think I'm having a bug where I can't load multiple pages at a time or in a row. I wonder if it's because it's trying to use like reuse the connection. If I refresh here, it's working. Oh, okay, there's something missing. Oh, there's also clearly a bug with TCP in here as well, given that I'm saying that I'm missing sequence numbers. Okay, so that seems okay though. So here, did I get my hello world? I did, so that script is definitely running. And I guess now, I think you can also put like a style block in there, if I remember correctly. Where you can put like style. And let's say that I put in like background is like black. I think that's how you do it. It's been a while. We'll just say that my HTML is not good. So I did get a background thing in here, but it didn't apply, probably because the background isn't like the right thing. Is it like color? Is it like this guy gets color black? HTML style background color. Not that it matters, but now I'm curious. How to set background color? Style. Oh my god, why is this page so fucking long? Just tell me what the background color property. Thank you. Okay, so in here, if I say that my background color is black, and then I think I put a semicolon, if I reload this page, it's not right. Fuck. Oh, maybe I need to make a selector for this. Cargo run. I guess we can actually probably just edit on the fly. Is it like you put like braces here, and I put like my selector as like anything, or I set it's like the body. Ah, there we go. Okay, so we have like a body background color black. Cargo run. Let's take a look. Sick. Okay, it's coming back. It's coming back. We're starting to remember. So our page is going to say we have like our memory allocator state. And then we're going to have a like div with an ID of allocations. I think you need to put quotes here for it to be XML compliant. Not that it fucking matters. And then here we want our allocations ID. So I think it's a number sign is how I get reference by ID. I want its like width to be 100%. I want its I think you put semicolons in CSS. Its height, we'll just say it's like 50 pixels. And its background color will be red, because this is like going to be allocated segments. Of course, I can't refresh without running the server or the operating system. Oh, sick. Okay. So here, that's looking pretty good. And now what we're going to do is on top of this, we're going to put like new divs that are the free segments. So we'll say class ID, or is it just class, I think, is free. And then we'll say for all free classes, we put the background color to blue. And of course, I can't fucking reload the page if it's not there. And then we have to actually give this guy a width. So I think we'll just say like, you want to like fill him. So we'll say that like height is equal to 100%. And then maybe we'll put his width to be like 20% or something. I just want to see him rendered. Are you making a map of the state? I quite like dropping to canvas or SVG for these things so I can make them dense. That makes sense. Yes, that is what I'm doing, and yes, there's like a real good chance that would be better, but I've never done that before, so I guess we're just gonna do it like this for now. I do like that idea, though. It does seem to, like, I think that I've seen other people do that too, because SVG, if I remember correctly, is just like another type of like XML document, and I think that if I remember correctly, it is quite straightforward to write that kind of thing by hand. Canvas, I think there's more complexity there, if I remember correctly, right? You have to like draw pixel by pixel manually, and I think that probably ends up being more difficult than what I'm trying to do, but we'll see. I think there's like an offset field too here. Offset. How do I like set my X position? X position. I think there's like, how do I set? Oh, left number of pixels here. Thank you. Margin left maybe? Yeah, here we go. Okay, so what we're gonna do is for each free segment, we'll put its margin left to be, I think that if I put two of these back to back, I'm gonna end up needing, like, the margin left will end up being the allocated space, and the width will be the unallocated space. So let's try this. We'll save. So I'll copy this guy back into the actual style. And if I have two of these guys, I expect to see two 20% blobs with 5% on the left of both of them. And obviously I have to run the server. And I only see one. That's not good. That's not good. I was expecting to see two. Position relative, maybe. Hard to run. No. So let's inspect. What am I missing here? Oh, it's because I fucked up. I forgot to close these divs. Okay, let's try that. Our run. And we refresh. We're close. These need to get packed in horizontally. So I think that you put them in a flex box or something? Is that right? Is that right? Display flex. I think that's right. Cargo run. You're saying display inline block. Maybe that's right as well. Or maybe that's more right. Let's see. Display inline block. Hey! Thank you. Dude, you guys definitely better at this than I am. Okay. Cool. So now all I have to do is make in my script fetch the allocation state. So I think there's like a fetch API, and I just say fetch API HT or JavaScript, I think. You can do these things many ways, depends where you're headed, basically. Makes sense. And I don't know where I'm headed or where I've started. We're just kind of randomly, we're just bumbling. Okay, so I call fetch, I get the JSON back, and I can log it. That seems really straightforward, really easy. So we say here that I want to fetch the allocations. I wait for the response. I probably have to put these in like an async function. So I think it's just a function in it. And then here I call init, probably. Fetch is glorious compared to the old way. Yeah, I remember using jQuery to do stuff because it was such a pain with like raw, what is it, XML HTTP requests or something? Yeah. I remember it was not nice. And this, yeah, it kind of makes sense that you would just get, I just want to fetch the data. That's like a reasonable API. Okay, so this is allocations, and we'll log the allocations. Cargo run. And here, now I should see in my console, uncaught. Network error when attempting to fetch resource. So what happened here? Network. So we tried to fetch allocations, but we got nothing back. Why the fuck not? So this was a, oh, what the? That's interesting. So this guy just never finishes or something? You didn't set the connection close header, probably. Like in my fetch API? This redirect follow, blah blah blah. And you probably don't have until keep alive. Yeah. Yeah, okay. See, I definitely don't handle keep alive on my server. I hand roll an HTTP server. Yeah, that's all true. And the hand rolled server is shit, right? And I also hand rolled TCP, and it's also not really working correctly. We were struggling earlier today with I don't close my TCP connections, and I'm not sure if that's required or not. It felt like it wasn't. Make sure. Yeah. Okay. So in the header, I set the connection close. Let's see. I see. And then I have to close the TCP socket, which I was trying to avoid. Oh, I see. So what happens is I like open I open a socket. I set my content length to set the response, and then he tries to reuse his TCP connection to do it again. Browser will pipeline the rec without close. Ah. So I don't actually have to close it. But I guess that there are those. I've seen that there's like 6 requests you can do at a time limit in Firefox by default, but I'm only doing a couple. Yeah, fuck it. Okay, thank you. You're a genius. Okay, main. So here I just inject a connection close. And we say close to string into cargo run. And we go here. And we got the result. Yay! Very nice. Very nice. Okay, so now I can, in JavaScript, walk over each of those. So I can just say, for, God, set shift width is equal to tab stop is equal to 2 and expand tab. Okay. So here I can say, what, for allocation in, oh, I forget the fucking JavaScript syntax every time. Is it allocation of allocations? Probably in like squiggle bracket or round brackets, and maybe I think I have to convert something to an array as well for let. Yeah, forgot about that. Let's just console.log allocation for now, and I'm sure I'll find out why that's wrong in a second. So here, console, so allocation is not iterable, so I think I need to do like object or array from object or something. Array from, no, oh, maybe it's because this isn't allocations. It should be allocations dot free segments, if I remember correctly. Cargo run. Refresh. Oh, okay, there we go. Yeah. So we're iterating over them, and now we can set the start to be, we'll set the start to be percent of like a percentage of the range, and we'll set the right margin to be we can set the right margin to be the size, also relative to the total length. So we can say for each of these we're going to create a new element. So I think that there's like a document create element div. Then I say like, then I add a class to it. So I'll say let divs equal this. Div, what is this, like add class, or classlist.add. Man, you're so much faster than me, fuck. Okay, class list, add, let's add the free class. And then we want to inject this into some section. So we'll call this allocations. Div, and then so we say document get element by ID. This is allocations, and I think we say like push or something. We say let allocations is equal this, and say allocations dot. I'll have to check in the console. Get element by ID allocations, and then there's like children. What append child nodes maybe push. I swear there was a way to just like insert a node. Append child. Thank you. This should be append child. Yeah. This is the one. So here I can say allocations append child, and this is just going to be div. Somewhere there's a way for me to like edit the style of this guy directly too. So I think it's like probably like style width equals, yeah, okay. So here I'll just take out this like width and margin stuff, and I'll set those in here. So here I should be able to say div.style.width is equal to 20, the percentage of the size. So this should be the allocation dot. I need to look at this again. So it's location minus start plus size. Location minus the allocations start over allocation dot start minus allocations dot end for the size. And then all of this needs to be turned into a string with a % sign at the end. And the margin right will just be the size over the total size. So we'll do the total size computation up front. So this is this guy here. We divide by the total size, and the margin right is going to be the same. This is the allocation size over. Oh, this is fucked, actually. This is wrong. We'll figure out the margin right after. Maybe we don't need to make a margin right, actually. We do. No, we need a margin left that's relative to like the distance to the last one. So we'll say that the last element location was 0. Here we'll have to put margin left. Margin, maybe underscore left probably, is going to be equal to what? So it's going to be the last element location minus this location. Or, sorry, my location minus the last element location over the total size. I forgot a times 100 in here. Because this was going to be normalized from 0 to 1, and we want 0 to 100. We need to do the same thing here. Camel case in JS land. I'll do what I want. You can't stop me. But yeah, I should follow the standards. But it's too late now. Well, it's not too late, but I'm not going to change it. And then I set the last... Oh! Thank you. You're right. You're right that this is a actual API of... that will follow their conventions. And then I say the last element location is just where we started. So this is probably this probably is like plus equal to margin left plus width or something. Margin. So this will just be let's think about this. Width is equal to this. The last end is equal... The last element loc is going to be the end of it, which means that the last element loc has to be plus equal to width. I think that might be right. So here, what we have, we set the width. The margin is going to be my start minus their end over the total size times 100. Sure. Last lm loc is going to be... Oh, this is in the wrong unit. So this is in percentage, which means that I can just do my location in percentage minus the last element end. And probably I have to like wrap this in some brackets to avoid some JavaScript conversion. And maybe that's right. Let's see. Gonna run. There's a good chance it's not right, but... Okay, so we've got problems here. Redeclaration of allocations. So what's going on there? Allocations. Yeah, that would do it, because we're getting element by ID. So this is, we'll call this allocations div. And this should be allocations div. We refresh. Unexpected token identifier. Where can I see this? Refresh. Can I not see? Oh, is it because it's in the file? Fuck. Unexpected token identifier. And I can't even see which line. Oh, line 18. Oh, here we go. Oh, it's just because there's like a W in there somewhere that I accidentally got put in here. Okay, gotta run. We refresh again. Document is not defined. What? Oh, it's because I forgot an E in document. Document. Here we go. Gotta run. Refresh. And create element is also not a function. God. I'm just gonna say that I hate dynamic languages, man. This is such a stupid way to test that I typed in the words right. Okay, so here I do have my elements in here. Did I put them in the wrong spot? So I have width equals 0, margin left is equal... Okay, so negative numbers, not good. So clearly our margin left is fucked up. And it's going up to 1,000%, also totally wrong. The width isn't even being set in these ones, which is fucked. Maybe because the width is getting set to 0 every time. So let's console log width. Cargo run. Where are we at? So here we're getting negative 99.99 over and over again. How is that possible? Our location minus start should never be negative. Right? Am I crazy? So what is our... let's see. What does our start here come out to? 188.7566. And our location is 188.7566. So the first one should be 0. It's negative 0. The second one should be way bigger than 0. Like, what the hell? So this should be this. Oh my god. Press enter to allow pasting. No need to type allow pasting. Okay, whatever. So this should be this minus this, which is much bigger than 0. So I don't understand where this like negative is coming from. We'll just log all these things. So allocation, location, allocation, start, total size, and width. Like, am I high? Like, oh, or run every time I forget. So one of these is negative. What the fuck? Okay, so first of all, I didn't even write the right word here, location. But here my allocation start is negative, and that I don't understand. Let me double check that's what came in on the, if that's what came in on the network. No. Did I just put a minus somewhere? What? I must have done something fucking stupid. I must have. There's no other play. Oh, this is allocations I'll start. This is total size. My total size is negative. Yeah. I was getting there, but yeah, you beat me to it. Just very, very slightly. Fuck. Thank you. Good catch. Okay. This looks fucked in a whole other sort of way, which is, you know, we're getting somewhere. So here we probably still just have this like width is too fucking fat again. Yeah, width 99.99. Oh, maybe that's actually right. For the first one, not for the rest of them. Right, because the first free segment is going to be like really, really, really big. Now my margin left calculations are, I think they were probably off by a lot here. So let's double check this. Width is our location minus start over total size. So that's also just wrong, right? This has to be, this should be size, not location. Let's see if that looks any better. Okay, so here we have width is 98 on the first one. Then we have a bunch of things where width isn't even set. Odd, right? I would think that for all of them we should set width, unless I'm setting it to like a bad number. So let's, we do try to log that every time. So we logged a negative number for width here. So that's a problem. Right, because why am I subtracting allocations.start? That's stupid. We just have the size of the total size. Duh. Here, then is our location stuff right? Margin left is the allocation location over the total size minus last element location. The last element location is plus equal to width, but this also has to be plus equal to margin left. So let margin left is equal to this. And here we put in margin left, and here we say plus equals margin left plus width. So for as we iterate, we increase by margin left percent, we increase by width percent, and we put the end to margin left plus width. Okay. That should be it. Cargo run. Okay. We're close, I think. So let's delete these guys from here. This is right. This is right. Cargo run. Okay. So what do we have here? We have a margin left of 1%. And is that correct? Our first element should have a margin left of 0, I would think. So let's just double check. We'll look at this response. Start is 566, start is 566. So yeah, our margin left initially is just absolutely wrong. So this is location over total size times 100 minus last element location. Let's log margin left here as well. just to see. Cargo run. Note 2, JavaScript numbers can't cope with 64-bit integers. That should probably be fine. But there you raise a good point that I might be working with invalid. I might want to convert everything to floats just so that the math works out nice. So what am I logging here? I have location, start. So these are the same. Total size, big for should be consistent. My width is very, very large, and my margin left is also quite large. And so this is where the bug is. The margin left should not be 1.4 here. So let's just double check. We have our location, which is the same as the last element locate, which is oh, here we need to minus start. There we go. There we go. So now we just have a giant blue bar with a tiny sliver of red at the end, and that's probably just because the vast majority of our memory space is probably unused. So I think what we can probably do here is we can look at the qemu wrapper that we like the qemu command that we run. We asked for somewhere we asked for 512 megs, I thought, or maybe we're using like the default 256 megs. I swear at some point we were asking for a certain size of memory, but I don't see that in here. I see device. So probably I just didn't write it down here. So qemu set memory size -m. So I can probably just put in here like -m512, like 50K or something. Try to make it small, maybe like 10K, like really small. That's probably too small. So let's try something like 512M at first, just to like see. Yep, we do. That's good enough. That boots. So let's try something like 64 megs of RAM. Is that big enough? Is that too big? Okay, that boots. And do we get like visualizations? We're getting closer. We'll try 8 megs. And here we go. We're starting to see allocations. Is 1 meg too small? 1 meg is definitely crashing. 4 megs. All right. So, oh, here we go. If I zoom in, I'm seeing something. Maybe I skip the first block. And maybe we'll get something more, we'll maybe be able to see something more interesting visually. So we'll say that we'll just rewrite the start as allocations start is going to be equal to allocations free segments 1 dot location. And there's probably a way to delete the first element from the array. Could be the BIOS or your bootloader doing high mem dance. i386 is just a wonky mess. I don't know what high mem dance is. High mem. High DOS. Oh, I see. So you're saying that like he's trying to figure out how much memory I have. If I have like the 32-bit expansion shit, and then oh yeah, okay, switching to protected mode, etc. Yeah, so he could be trying to figure out like if I have what is it like real mode x86. He could be trying to figure out if I'm in the like 32-bit mode or the 16-bit mode, and if I don't have enough RAM, it just like fucking crashes. That's not surprising at all. Yeah, there's all sorts of things it could be. I wouldn't be shocked if it's just like my kernel's taking up more than a meg. I actually just realized you're doing QEMA a kernel jump thing, right? So it might be your kernel's too big for RAM. Yeah, I think that's very likely. Let's actually see. You've got me curious. What is it? Kernel, target, debug. What the hell? ls target, debug kernel? What the? Target, kernel, Target, right, because for some reason they put it in a double target here. So this is do.h 8.5 megs. Holy shit. So actually when I'm 4 megs, it's also just like totally fucking invalid. Whoopsies. That's okay. We'll take the failure for now. What was I trying to do? I was trying to skip the first segment in this visualization. So allocation size, my total size. Right. I was trying to see if there's a way to delete the first element in an array. So JavaScript array pop front shift. Does it just shift removes the first item? Yeah, okay, that's what I want. So we'll just say free segments shift. So this should delete the first element. We've remapped the start to the first element, and now we should probably get like a more zoomed in view of our allocation state. Dude, this is such a boring look. If only... I mean, I do see like slivers and stuff in there. I guess I can delete the last one too. So like pop. And maybe we set this at the end. I guess like I'll just set the end manually. Just say that like... I guess it's possible that our allocations are just fucked as well. Or that the like visualization is fucked. Cargo run. Refresh again. Let's just double check. So maybe we should test this with something that we like know is sane. So here we can say allocations is equal to start 50, end 100. And then we have free segments. And in here, this is an array, and we have locations, or we have one that's at like location 55, size 4, and one that's at like 80, size 2, or size 10. Right? This will at least give us a good clue for if our visualization is working at all. I fucked up my syntax there, so can I just click on this and see where it is? I forgot comma, obviously. And now if I refresh, allocations, can't access lexical declaration allocations before initialization. Sure, so I'll just nuke all of this. Cargo run. Total size is not defined. That makes sense. So we'll just put this down here. And we need this guy as well. We need these. Okay. Cargo run. And allocations div is null. Fuck off! Allocations div. Wait, what did it say? Allocations div is null? Why? It shouldn't be. Oh, maybe I have to like, do I have to wait? I think I'd write like defer equals true here, and we were just like getting lucky that, or maybe just defer. We were like accidentally running this before we loaded the page, but we were just getting lucky because the fetch took so long that it was running after the page actually loaded. There we go, and allocations div is null still. Script defer. Script defer. Could have sworn that was right. I'm missing something. Well, we'll just we will just wait for the body again as a workaround for now. Target run. Reload the page. Okay, so that visualization looks pretty reasonable, right? So we have about like 10% in, a like maybe 6%. Yeah, that looks like about right. So I think that the raggy in chat, the raggy, I think he's probably right that these allocations that I've got are just so fucking small that they're not visible in this view. So all of this was kind of a wash because actually visualizing the allocator state is like not useful with this visualization. But I think I'm happy with like the concept, right? We've kind of proven to ourselves that we have like an HTTP server and we can like propagate useful information up from the like OS about stuff. We can like get it up here, and if we were a little bit cleverer, we could make a visualization for stuff like this. And we also know that we can we could start like putting actions in this web page, right? We could say like if you want to toggle debug state of stuff, you could like put that in here. So I think I'm happy just to know that this is possible and it would work if we had like a better viz. And I think I will call it there for today. Thanks for watching. If you want to tune in another time, I'll be streaming most days at around 2 Pacific time. And if you miss and you want to catch up, there's like YouTube links in the description on Twitch. And if you're watching on YouTube and you want to catch it live, there should be a link in the YouTube description. So thanks for watching. Catch you on the next one. Bye.